Okay, today I'm going to teach you how to add vectors together. So I'm going to share my whiteboard on which I tried to draw some graph paper. So here's my whiteboard. And if you remember, a vector is something that has a magnitude and a direction. So if I draw a line, that can represent the magnitude of the vector. And then if I draw an arrowhead, that can represent the direction of the vector. So this vector is going 1, 2, 3, 4, 5 in the x direction. And let me draw a vector that's going in the y direction. And I'll make this one go 4 in the y direction. It's a little bit sloppy, but hopefully you get the idea. Now, if I want to add these together, there's an easy way to do it if they are perpendicular, which means that there's a 90-degree angle between the vectors. And that is just find the diagonal of the square, and you can add these two vectors together by drawing the diagonal. So this vector that goes 5 in the x direction added to this vector that goes 4 in the y direction equals a vector that goes 5 in the x direction plus 4 in the y direction. And I want to teach you this word component vector. So a component vector is a vector that when you add it to another vector gives you your resulting vector. And when I draw vectors like this where I drew one in the x direction and one in the y direction, the one I drew in the x direction is my x component of this vector. And the one I drew in the y direction is the y component. So let me change the colors a little bit and draw two new vectors. So I'm going to draw an orange vector, and I'm going to draw a green vector. And the vectors can, these two vectors add up. I'll make the resulting vector be red. And the green vector is the y component. In this case, it's -2 in the y direction. And the orange vector is the x component, which in this case is 5 in the x direction. And they add up to a red vector that goes 5 in the x plus -2 in the y. I don't know if you noticed, but I drew that resulting vector a different way. I didn't make the diagonal. What I did was I put the vectors head to tail. So that's the second way. And let me show you why it's important to be able to do that way, putting vectors head to tail. Suppose that my vectors were this vector and this blue vector. Oops, kind of sloppy again, but you get the idea. All right, so this time, my blue vector isn't just going in the y direction, it's going 2 in the x plus 4 in the y. So it's a little bit hard to find the diagonal of that vector. But what you can do is you can take this blue vector and you can move it. I'm going to use this little red. So I'm going to just move this blue vector to the right, and I'm going to redraw it. So I'm going to put the tail of the blue vector on the head of the red vector. So the head is the part that's got the arrow, and the tail is the part that doesn't have the arrow. And so that's how another way I can add these two vectors together. So I get a resulting vector that goes like that. And that's actually the diagonal of this parallelogram that has these two blue vectors as two sides, and there could be another, I could draw a red vector up here. So one thing you might want to notice is it doesn't matter Whether I put the tail of the blue vector on the head of the red vector or I do it the other way around, either way, I get to the same place. So that is how you can add vectors. You can either draw a diagonal, or you can place the vectors head to tail, and wherever you wind up, draw a new vector from where you started to where you wound up, and that's your resulting vector. And that is it.